join.
That's right. All right, this is Group 7, Lesson 16. All right, so Part 2, it said open up the file class survey using the file format for your class. Create a pie chart. So were you guys able, this I'm going to show you guys because that was what was in the video. Let me go share this screen. So, okay. So here's the, oh, okay. I'm going to actually click out of this output just so I can show you. Okay, did that just go back to me instead of?
Mm-hmm.
Let me try and share the screen back again. Okay, so when you're doing this and you want to create the pie chart, this doesn't look like one that has to have the weighted information like they talked about. So, so you guys can see the chart here, the class survey.
Uh-huh.
So to create the pie chart, you go to Legacy Dialog Graphs, then Legacy Dialogs, then down to Pie, and hit Define. They wanted rank. It says create a pie chart for the class rank. Label it and post it here. So I clicked on rank, put it in define slices by, and hit OK. And then I'm going to go over here and you can't see the pie chart yet, right?
No.
Okay. So I'm going to stop sharing that one. I wish it would just follow everywhere you went instead of make you have to
Instead
open
of like
up
a screenshot.
Right.
Is that you, Chris?
Yeah, she's on mute again. I can see it. Okay, so here's the pie chart that came up. And to label it, you would go double click on it. Pulls. Where'd my edit screen go? Chart editor. Stupid thing. Okay, I'm going to go back to share another window with you guys. Okay, so there's the editor, and down. Oh, okay, so it's asking us. I'm just going to skip down to 8 because this is where it said show at least 5 ways, graphs, and numerical statistics to describe the data above. And they're talking about this pie chart and the bar graph. And I was like, I can see that they're split up, but I don't know. I don't have any numerical data. And so when I watched that video, they said to go to Elements. So you've got on the chart editor. You go to Elements. And then you go down to Show Data Labels. Click Data Value Labels. And we want, there's the count in there. It splits up how many people fit in each category. But also we want the rank, or the percent, I should say. And you throw it up into that window and hit Apply. And can you see it now? Can you see that now where it shows the percentages on there? And so then you would go down, and so you'd put freshman. And if you look and find, oh, I guess you guys want to see the rank then if we want to know who it is. Okay, let me do that again. So you go to Elements, Show Data, Data, Value, and Labels, and then put rank up there too. So we're going to hit Apply.
Scared me.
Woo, it scared me. Stupid dog. Anyway, so now you can see it. It says their rank, so junior, freshman, senior, sophomore, and the percentage of those are our stats. Those are our numbers. So freshman, it's 4.37% or 0.0437. Sophomores 0.4098. Juniors 0.3224, and seniors 0.2131. So those would be our numerical statistics. You can do it also with the bar graph. You do the same thing. You would just go to, good night, Moon. Sorry,
Hi,
that's
little
my little
buddy.
boy. Can you say hi? Here's
Hi.
He's so cute.
Say thanks. This is my friend Carrie. He's like, I can't see nothing except me, which is good. Okay, go to bed. Love you.
Okay.
So you can do that with a bar graph too. When you just double click on it and it goes to the editing, and you can put those same numbers on each bar by going to elements. Okay. All right. So then they wanted us to do a bar chart. Were you able to do all this? Do you want me to share the screen once I get it done?
I don't mind. Eduardo or Chris,
Yeah.
you
Are you guys here?
Hey, I'm here.
do you want her to show go over the bar chart,
Yes.
Oh yeah, sure. Yeah, that'd be dope.
especially
Okay.
if it's a dessert bar?
That's right. I want a dessert bar.
Oh yeah.
Okay, let me go.
When I'm
ahead
done
and
with the
share that.
semester, I'm like eating a cheesecake.
Oh yeah.
How'd you do on the exam?
I don't want to talk about it. It was all right, I guess.
No, I bombed.
It was brutal.
Like I was like,
Yeah.
where was this information? I don't remember. Like, I felt it
felt
was
really
very
good.
just.
I felt really good taking it, you know. And then I saw my score, and I'm like, what? How is it even possible?
Yeah. Well, it threw me off getting in there and having all those things from the percentile questions and I was like, oh crud, I don't remember. Yeah. The other one that was really hard that I remember was when they were asking you to define whether it was an independent sample or dependent sample, and it was the I don't know if we all have the same questions, but for me it was this court rehabilitation program.
Mm-hmm.
And at first it seemed like it was independent. You know, they're picking these guys for the rehabilitation program, and these guys for the non-rehabilitation. But it didn't seem at first that it mattered who was picked for what. But the more I read it and paid close attention to the words, it started to confuse me, and I spent forever on it trying to figure it out.
On that one,
Probably.
I did it as a dependent because they said they had to match out exactly the crime and
Yeah.
the
Yeah,
sentencing or something like that.
it was their age and their social status that they carefully matched by age and social status or something like that.
Something,
So
yeah.
I marked the same thing. So, but yeah, I don't know. That was hard.
I have never
hard.
felt so dumb in my life.
Oh, it was hard.
You know,
Okay,
so often I'll get something in the school and I'm like, school is supposed to make me feel smarter, not dumber.
Right.
That one was one of those. Like I had a hard time sleeping.
Yeah. Oh,
Sorry.
Exactly. I had statistics running through my head all night. It was really bad.
A nightmare.
Yeah, it was. Okay, so there's the bar chart, and I was telling them, like with the pie chart, if you double click on it and go into this chart editor and want to see the percentages, because they're going to ask for statistical numbers, you go up to elements, and then you click show data labels, and then you put percent and rank up into the displayed window out of the not displayed and hit apply. It shows you, can you guys see that? The little percentages.
No, it hasn't.
No, because it's I have to go and show the right window. Let me, sorry. Because every time I open a different window, it does something different. Okay. All right. So there it is. So it shows those, and then they wanted us to, and then you guys know how to do is it called the Pareto? Where you click on here, and then I can't remember what do I do from here? I have to go back and look. Oh yeah, edit, properties, to statistic and descending and hit apply. Okay, so there's the Pareto thing. All right. And then, Eduardo, were you here when we were talking about they wanted question 8? They wanted at least 5 ways, so graph and numerical statistic to describe the data.
Number 8? No, I wasn't here. I just got here. I actually just got back from taking a test.
Oh, exciting and fun. Very
Yeah,
fun.
so much fun in Rexburg.
Yes.
Are you guys
that's
still like
right.
snowed in, or is it kind of melted?
No, it's still snowing. It was snowing this morning. It's freezing. It's like 25 degrees, I want to say. So it's been
Yeah.
snowing all day. It's crazy. I actually came home. I was coming back from Utah this week, and it was bad with the snow.
Oh, I bet. Yeah, we got dumped on this weekend here in Utah.
Yeah, I was there. Yeah.
Yeah.
So, Eduardo, are
Sorry.
you originally from Utah?
No, I'm from Georgia.
Oh, so snow's kind of
Yeah.
not a normal thing for you.
Yeah, snow is non-existent.
Well, I grew up in California, where I can remember one time where we got this ice storm that kind of coated everything, so it
Okay.
looked like snow. I mean, and then since moving to Texas, we have had snow, mostly ice, and in the last 2 years, we've had very mild winters, and we haven't had anything.
Wow. Well, this winter has probably been in Utah. When I was a little kid, we got tons of snow. I grew up here in Utah, and they would cancel church sometimes in school, and we haven't seen a winter like that for, I don't know, 15 years. But this winter's just dumped and dumped and dumped on us. It's been kind of nice.
Have you had lots of stuff canceled for the weather? Or?
No, actually, that's what's funny. They haven't canceled anything. They've allowed, like at school, for kids to be later. You know.
Oh, that's nice.
Yeah.
They have, well, they haven't done it in many years, but sometimes they'll do like a late start, you know, if it's like really icy or something in the morning, but we haven't had that in a long time.
Yeah. Yeah, it makes sense. It's smart. Okay, so Eduardo, for question 8, these numbers on these, can you still see the bar chart?
Yeah.
With your percentages.
It just went away. Okay.
Yeah. So these are the statistical numbers they're asking for. So you could write freshman rank, and you see that down there. It's got 8 people anyway, 4.37, or you could write it 0.0437. Anyway, and then sophomore at 0.4098, junior at 0.3224, and senior at 0.2131. And then they have this other whatever it is, 0.0109. So those are the numbers they were kind of asking for. I was telling her that I didn't know how to do that. I was looking at going, how do I get this? But there's the 3rd video on our textbook that if you go watch, he shows you how to do all that stuff. But anyway. All right. So then question 9 says 7% is the true known percent of the population that do not have traditional phones and instead rely on cell phones. So 7% is P, which is our population mean. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, or 8%, in the survey use only cell phones? So we kind of go back to, I can't remember what lesson, 9, 10, but use different symbols. So it asks, what is the mean and standard deviation of the sampling distribution based on 750 telephone users? Well, so the mean would have been that 7%. It's the true unknown percent of population. So the mean is, or P, in other words, is 0.07. And then, do you guys get how to do that? Find the standard deviation after you know what that mean is. It's the formula that is the square root of P times 1 minus P divided by N. So that P times 1 minus P divided by N is all under the square root, if that makes sense. So putting the numbers in that, it would be 0.07 times the parentheses of 1 minus 0.07 divided by 750, because that's our sample size. And then you take the square root of the total of all that.
They'll
And
just
so
make you grab data from anything and plug it into a z-score.
that's right.
Jeez.
Right. So I solved the parentheses first. The one I put 1 minus 0.07. You could do it either way. You could do the distribution anyway, but and then times it by 0.07, divided it by 750, and then took the square roots, and it gave me 0.00931. And you want to kind of keep a long number before, just because it won't give you some interesting answers if you don't on the next question. Okay, does that make sense?
Mm-hmm.
Okay. Go ahead, Carrie.
I was just going to say, I guess I just need more examples of, of pulling the information. Once again, the world's worst word problems and pulling information out.
Yeah. Right. It is. It's learning it's learning the new language, right?
Oh, yeah.
That's what it is. Yeah, because like one of the examples he did in the videos, he was like, okay, we want to find this, this, and this. So what would the p hat be, And I was like, I don't know, you didn't give it to us. But he was saying, well, in order to win the election, it would have to be over 50%. So we're going to say 0.5. And I thought, oh, great. You mean I have to think and figure it out? I just want you to give it to me. But okay, so the next one is, what is the z-score you would use? And so we find that formula that they gave us for this lesson. The z-score is p hat minus p divided by the standard deviation that we just found, the 0.00931. So in the description above, they want to know what the probability that is more than 60 phone users, which then they gave us that 8%. So that would be our p hat. That's what we want to try and figure out. That's kind of our sample mean. So it would be 0.08 minus 0.07 divided by the standard deviation, which we decided was 0.00931. So 0.00931, and so that gave me 1.074. On the answer thing it said 73, so I bet if we added more than if we took like 8 digits off that original answer, it would give us 73. But so 1.073 is what we'll say.
Did you use once you found the z-score for B, we plug it into the app, right?
Yeah, just the normal probability app.
Oh,
just go put in.
And then because it says more than 60, we have to do to the right?
Yep.
Crazy.
I know. We're back to ground zero, but having to learn a new language with it.
Exactly.
So you shade that right area after you put in 1.073 as a z-score, and so the probability is 0.1416. So way exciting. All right, so that was that. Now let's go into the quiz, because we're all ready for this.
You ready?
Totally. Okay. All right, move thing. No, move. Okay, I'm getting there. I hope Carrie can hear us.
You mean Chris?
Chris, yeah, Carrie can hear us. I hope Chris can hear us, because I can't hear her. Okay. All right, 1 and 2. Wait, yes. Freebies. Okay. Okay. When calculating anything, please remember. Okay, same stuff. All right, question 3. In a pie chart, why are the slices, sectors, different sizes? Really?
Because things are different proportions. I don't know.
Yeah, right. So A is the size of each slice is random. The size of each slice is determined by the number of categories. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. And pie charts are more visually appealing when the slices are different size. I like those answers.
C.
C. Hey, was that Chris?
No, that was me. I was laughing.
That was you. Oh, okay. It just echoed through. Okay. Yeah, I agree. C. Okay.
Oh my goodness.
that?
How are bar charts and Pareto charts related?
I like the Pareto charts are constructed from tossing a coin several times.
They're identical.
Okay, so yes, the only difference between a bar chart and a Pareto chart is that the bars in the Pareto chart are ordered largest to smallest, going from left to right. I would say C. Because you create the bar chart,
and then you
click on it, rearrange it. Yeah.
Okay.
Okay.
Use the following
So
information
far,
for the
so
next
good.
3 questions.
Okay. Okay, we conclude that P is normally. Do you guys understand this thing? So in order to fit the central limit theorem, this is what you base it against right here. You take the sample size n times P, and it has to be greater than 10, greater or equal to.
But it has to be both.
And
Both
yeah,
have to be true.
right. And the n times 1 minus P, right. So, okay.
No,
All right,
never mind.
go ahead.
I was gonna say, I see in the reading where they use the P with the little hat, and then like the NP. So, like, is it the same thing, or is the P with the hat equal to the NP? You know, I was just a little confused on their verb, like how they kind of like flip flopped it.
You mean just the regular P versus the hat P hat?
Yeah. Because, like, for example, like at 3.21, it says, how can we apply the central limit theorem? Sorry, we're already in the test, to a sample portion and conclude that the P with the hat follows on not a normal distribution if both of the following conditions are satisfied. And then it does, you know, so, but then down further, it says the mean of P with the hat equals P. And the true population standard deviation.
Right. It is a little confusing. I'm with you.
I was just wondering but anyways, so
P is the true population or true population proportion, and the mean of the distribution of P hat. If that makes sense. That's the definition I got. It's the mean of the distribution of the sample. So on question 5, I would say it's the true population. That's my guess.
Proportion?
Yeah, sorry, I say population, but that's because I'm going back to the other language. Going back to my first language.
Ain't that the truth?
Yeah.
I could barely get what we did. Okay, and then so N still the sample size, right?
Yeah.
That hasn't changed.
No, that one's still the same. We're good. Okay, it's question 7. If P is 1/4, we can. What is N that satisfies the requirement? So if P, we could say is 0.25 because that's what a quarter is. But what do we have to get to make it 10? Well, if you put that into equation, wouldn't you divide by 0.25, 10 by 2?
I would say, wouldn't we just solve for N?
Yeah, that's what I was thinking. Does that sound good, Eduardo?
For number 7?
Yeah.
So we put 10?
Well, so it wants to know what n would have to be in order to make this true. So we figured just solve for n.
Well, but because it doesn't have an equal sign, can we divide?
Well, it says it has to be greater than or equal. So in order for it to be greater than it would, or it has to be at least what it's equal to,
So
which I got.
Then 10 divided by 0.25 is 40. What? Is that right?
Yeah, that's what I got as well.
40.
Let's see. Yeah, let me see what n.
Oh, because there's 40 quarters in a 10.
Yeah. Let me see what happens if we solve for the other one. Okay. Huh. 1 minus 0.25. So n is 0.75. Huh, because the other one would be different. Oh, no, it wouldn't. Let's see, wait. Yeah, it would. Oh, what? Sorry. Not nimble fingers. 14.3. Okay, so what's the question? Let's see. If p is, what is the smallest n that satisfies the requirement? So my question is, do you have to solve for the other one? If it has to be both? Because if you solve for the other one, the n times 1 minus 0.25, it would be 13.333333 forever. So I don't know.
Okay, hold on. Well, remember for laws of operation, you would do the 1 minus 0.25 first.
Yeah,
And,
which is 0.75, right?
right, and then you would divide times in the n, so it'd be 0.75 n is greater or equal to 10, so divide it, and then n, so 10 divided by 0.75, I got 13.333. Is that what you said?
Yeah. So I don't know which one to put. We could just pick one. What is the smallest n that satisfies the requirement?
If it's the smallest, then it would be the 13.33.
333 forever. All right, well, let's put it down. And
Maybe divide it. I would do out the 3 placeholders.
I would just go 3, yeah.
Okay.
So we're doing
I think
40?
No, because it asked that what's the smallest n. So
Okay.
Stacy and I are thinking the 13.333.
13.333.
But we could be wrong.
Yeah.
And
Yeah. So I'll turn it in and then we'll see what happens and then we'll go from there. Okay. All right.
And for what is n is the sample size, right?
Yeah, n is sample size. Okay, question 8. Use the following information to answer the next 2 questions.
Okay, what's the mean of p with a hat?
Well, isn't that the formula? Well,
isn't that the p equals x over n?
Actually, I believe this is where that's what at first I was thinking, but that's only if you have like 80 out of 1,024. That helps get you to p. But in this, remember that we were saying how confusing where it said p equals p with a hat? I think this is that situation. So I think it's 0.4.
Oh, kind of like we didn't we have a quiz like that where we were like, it's right there in the answer. Right. Yeah. So, and then the standard deviation of p would be the square root of p times 1 minus p over n, right?
Yeah, yep. Over, what was n, 24?
Let me get some scrap paper. Ugh.
I know.
I think I've used up a tree in this class.
Okay.
Square root of p is 0.4 times 1 minus 0.14 divided by n is 24. Oh my goodness, scientific calculator is my friend. Okay. 0.4.
Oops, let's see.
1 minus 0.4 divided by 24 equals
I got 0.01.
I got 0.61913918736.
Okay.
And how I
So
got
I'll
that
go over it
was
again.
I did 0.4 times 1 minus 0.4 divided by 24, and then you square root that. So the order of,
Oh, that's why I forgot to square root it. Thank you. Okay, but then I got 0.10000. So let me go over my numbers again. So if I take 1 minus 0.4, I get 0.6. I times that by 0.4, and I get 0.24. And then I divide that by 24, and I get 0.1 or 0.01, and I take the square root, and I get 0.10.
okay,
I don't know.
I did the 1 minus 0.4 first, and then times it by the 0.4
Yeah,
because
just
of
do
order.
that by itself.
So 1
Just do that
minus 0.4 equals 0.6
times
times
0.4, right?
0.4 equals, oh, and then divided by, I think I did my order of operations wrong. 0.01
Well,
square root of 0.01 equals 0.1. Is that what you got?
yeah, it says round it to the 10th, which
Isn't that the
is
10?
0.1. Yeah, right? Yeah, 0.1.
I concur.
Okay. Oh, I see. I wrote it down wrong. Okay, 0.1. I would have gotten that wrong. Ah, all these points. Okay. Use the following information to answer the next 4 questions. Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 bats. Let me look at that. What's 35 divided by 100? That will give us, okay, 0.35. Okay, so they're giving us, so P is 0.3, right? They give us that one.
N equals 100.
On the first question, they want to know what P hat is. Well, that's the mean. And how you find it, see, they want to know what, this is where it's getting confusing, because remember up above we said, well, P hat was equal to P. Well, in this situation, it's not.
Because they've given us more information.
They've given us more information. So they want to know, okay, they want to know if she'll get more than 35 hits in her next 100 bats. So that's kind of where we get P. That's where the P hat equals X over N. So you take 35, which is, and divide that by 100. 35 is X.
0.35.
It's sorry, 35 is X. It's the number of categories they're looking for, or whatever. That you divide it by 100, and it gives 0.35, which is what they want us to solve for probability-wise. So I would say 0.35 for 10. Any other thoughts or reasoning behind that? Because I'm not absolutely.
Too.
Said that again.
I agree with you.
So wait a minute. So this is where we're going to do that equation first. The P with the hat over X over N. So then 35 divided by 100. I just want to make sure I'm on the same.
Okay, I'm getting a little confused here myself, because I'm like, wait, though. Yeah, because the P hat, oh man, I don't like these questions. Because if you look up above, they ask the same questions. What's P hat? What's this? But we used the information. It was 0.4. So I'm wondering if we still need to use the 0.3. How about this? You guys solve for 0.35, and I'll solve for 0.3, and then whatever answers Does that make sense? I'll turn in mine first and see what happens. So I'm going to put point, unless you guys just want to do it one way and then we can go back and do it another.
It doesn't matter to me.
Oh, except that it says round to 2 decimal places. That kind of gives me
The impression
pause
that
yeah. So, okay, for standard deviation though, I still want to solve it for you would use the, well, I don't know what you would use, to be honest. Okay, let's just use the 0.35 and see what happens.
it's okay.
And then if we need to, we'll redo it. How's that? Okay, so we take 0.35 times 1 minus 0.35 over n, which was, do we say 100? It was 100. And then square root all that. Don't let me forget that part, because that's where I mess up.
I'm ready to compare answers when you are.
Okay. I'm almost there. Okay, I got 0.047, and they want us to run it to 3, so 0.048.
That's what I got.
Okay. 0.048. Okay.
And crap, we're back to z-scores again.
Yeah, and the z-score, I'm not, so just keep that 0.48. So then what you do, the z-score is p hat, which was 0.35, minus p, which is 0.30, divided by our standard deviation, which was 0.048, if we got it right, but we'll find that out in a second. Okay, 0.35 minus 0.30 divided by 0.048. Ah.
Which one's our mean? Sorry.
Well, the p hat is 0.35.
Oh, that's
and
0.03.
the point minus 0.03.
And then our deviation is 0.048. It's going to be one of those things oh, wow, we have some crazy numbers. Oh, look, it worked.
I know. It might work.
I always love those moments.
I know. So I got 1.042.
Yep, that's what I got.
Okay.
So
All right.
we are all either on the same bus to heaven or
Well,
hell.
So if they tell us that our standard deviation is wrong, we'll know where it's wrong and we'll go back and fix it. How's that?
I think that's why they do it the way they're doing, like they're building on each answer.
Yeah.
And then so
we want to know.
Now it's asking what's the probability. So that's where we're going to stick that z-score in the probability app, right?
Yeah.
Which, here we go.
And it said if they wanted to know if she'll get more than 35 hits, so you highlight the right, so I got 0.1487. Do they want us to round it? Probably.
1.149.
Yeah. So 0.149. Okay. Oops. All right.
All right. Now we're on to some more.
This is a long quiz. Okay, this is our last section.
Because we're totally onto that where just to get one answer, you have to do like multiple steps.
Yeah. If the true population of people who supported a political candidate was P equaled 0.52 and N was 2,000, people are surveyed. We want to determine if the probability that the results of the survey suggest a candidate of losing election, so getting less than 50%. So we're going to, the p hat, the thing we're going to test against is 0.50 and less than. So here's that one question again. Use which p do you use? But we'll just figure it out anyway.
Well, if we go back to p with a hat, then we use x over n.
Well, on this one, they gave it to us because they said less than 50%. So 0.5 will be our other number. it'll be, so if we use the p hat as the standard deviation, then it's 0.5 times 1 minus 0.5 over 2000.
How do we know that that's the P with a hat?
Because it was in the video that I watched, and I was like, so what's your sample mean? And that he told me because it's a political campaign. To win or lose, it would be at, over or under 50%. So that's why. Okay, so times 0.5. Oops. Okay, stop. 0.5 times. And then remember to square root it, or take this. Yeah, square root it.
Times 0.52
1.
divided by 2000.
And then square root it.
0.00012.
Let's see, I'm going to double check mine. All right, 0.5 times 0.5 equals divided by. Sorry. I got 0.011.
Yeah, that's what I got.
Okay.
What'd you get? Sorry, what'd you get? 0.001?
Oh, 0.011.
And then for our z-score, the value minus the mean.
Yeah, so it would be 0.5 minus 0.52 for our z-score divided by that standard deviation we just got, the 0.1011.
So which ones are mean again? The P, 0.52?
The P, yeah. So it's P. Go ahead.
No, go ahead.
I would just say it's P hat minus P for the z-score.
Okay, so it's
Divide-
0.5 minus 0.52
Yeah.
divided by the 0.011.
Yeah.
Is that
So
what you,
yeah.
how you're setting it up?
Yep. So I got
22.727.
So did you do 0.50 minus 0.52 divided by 0.011 for the z-score?
I put 0.5, not, oh, so it's 0.05?
No.
That would make it, oh.
It's 0.50 minus 0.52.
Oh, that's weird. It looks like, let me do that again.
So I got
0.5 minus 0.52 divided by 0.011. Oh, that's where I got that 0.02. Oh, now I have a negative number. What?
Yeah, negative. No, that's what it's supposed to be. And I got negative 1.818.
Wait, what?
Negative 1.81818. So if we go to the, where's my thingamajig?
Normal.
Oh, there it is. So a negative 1.818, and then the question was losing less than 50%. So then would we do to the left?
Yeah, it would be to the left. I'll take off this. So I got 0.0345, which I'm sure they want us to round it.
So 0.35, right?
Yeah,
What's
0.035.
this?
What was that?
Is this for z-score?
The z-score we got was negative 1.818.
Negative 1.818.
Yeah.
Okay. I thought that we were doing z-score. Oh my God.
Okay.
And then
I'm going to submit
0.035.
0.035.
The probability.
Oh, yeah.
Okay, so let's go see. Let's see what happens. If those questions are wrong, then it's just because we used the wrong p-value and they'll be easy to fix. Let's see what happens. Okay, they were. Oh wait, weird. Okay, so we missed 12 and 13.
Oh, I
That's
thought you
it?
said you missed 12 questions. I was like, what?
That's all we missed was 12 and 13.
Yeah. So what
What is the Z?
that's,
Our Z score is wrong. Crap.
that's weird. That's so weird. Okay, let's try the z-score again on those. Okay.
So work it out again.
Let's try that again.
So our P with a hat is okay. So 0.30. So standard deviation of P with a hat.
Right. So we got our
So-
standard deviation right, but that doesn't make sense.
Are we supposed to put, because we figured out P with a hat, are we supposed to put P in a hat, the value of the P in a hat equals P, the square root of P minus, you know what I'm saying?
Yeah.
Like, are we supposed to plug that 0.35 into our, but we didn't on the bottom one, and we got that one right?
Right. That's why I'm a little
So
confused.
I wonder if it's a typo.
I don't know. Well, let's try this. Okay. P is 0.35. P hat.
P equals,
Okay,
Point-
standard deviation says it's P hat minus P over the square root of P. Let's try that. Let's try this. And I'm gonna have one of you guys turn it in. So for the z-score, let's try this. Go 0.35 minus 0.30, and we're gonna change the bottom. Do 0.30 times 1 minus 0.30, divided it by n, which was 100. Let's try it that way and see what happens with this answer. Okay.
how do you want me to set it up?
Okay, so do 0.35, that's p hat,
Uh-huh.
minus 0.30, which gives us, that's just the top of the z-score, so that's 0.05, and then divide that by, so do 1 minus 0.30 times 0.3, divide that by 100.
I thought we were refiguring out the standard deviation.
No.
I am. Well, I am, because so it asked what the standard deviation of p hat was, and so we use the 0.35 to get that standard deviation. But if when you go and it asks what the z-score is, that's where I'm just confused. I don't know. We're gonna try this and see what happens. It says p hat minus p over the square root of p times 1 minus p. So we're gonna put p in for this standard deviation. That's what we're gonna try, and then if that doesn't work, then we'll scratch our heads.
So instead of using 0.03, we're going to use 0.35.
No, we're gonna. So originally we used 0.35, I think, in our standard deviation. We got the 0.4048, and we used that the first time we tried the z-score. So we're gonna use it differently. We're gonna use the 0.30 in the z-score standard deviation. Does that make sense?
I thought that's how we used it originally.
I used 0.35. At least that's what I have in my notes. Let me see if I get something different.
What did you put down for answer 11? Ooh, is this the one
0.0?
0.048.
No, it was just it's 0.048.
Okay, that's what I put too.
Yeah,
That
point 0.048.
Okay.
Okay.
I thought there was one where we were going to go different answers, or did we decide not to do that? I don't remember.
Yeah. Okay, let's see what happens here. Let me square root it. Okay. All right. 0.05825. Okay, let me just a second. I've almost got the new z-score. Divided by 0.045825. Okay. All right. So the new z-score I got for this was 1.091. And then let's go put it into the probability. And we wanted to know the higher. Let's see. 1.09. 0.91. Okay. Okay, so the new p-value then would be 0.137. And do they want it rounded?
Round to
So
3
it'd be,
decimal places.
Mm-hmm. So
okay,
one
so
point.
it'd be 0.138.
Isn't that what we got last time?
No, we put 0.149.
Yeah.
Oh.
So who wants to try that one? So
I'll try
for
it. So the z-score, we did 1.091. I'll submit it.
yeah. Okay, submit and see what happens.
Right. I have number 7 wrong.
You do? What's the answer you have there?
The third.
Oh.
Oh, that's where we went differently. I did 13.333.
Oh, right. That's the one that we were questioning.
Okay.
Okay.
So everything else is
Shoot.
correct.
Okay, so put 7 down as, didn't we say 0.40?
Number
Then
7
was it-
0.40.
No,
Or no, not 0.40. It was 40, right?
you did 40 and I did 13.333.
I didn't do 40. I actually did. I just missed it when I was going through. So, Eduardo, you're going to need to put 40 on 7.
And see if it accepts it.
Okay.
But everything else is right.
Okay.
Wait, you got 12 and 13, right?
Yes.
Yes. Okay. So what happened? That's so confusing because anyway, I don't know what to say on that.
To get the answer you just did, we used the p that's in the problem, right? The point.
Right. We used the true mean proportion. Yeah. But why I'm confused about it is because below we didn't. We used the p-hat. That's why I'm a little bit confused. Because on one we did it one way, on one we did it the other, and one was right and one wasn't. Anyway, I mean, anyway, I don't know.
Yeah, I don't know if we did or not.
Okay, so Eduardo, you want to submit and see what you get?
Yeah, give me one sec. It's just my internet's slow. So 40,
You're
right?
fine.
That's
Try
what
40.
All right.
7.
Ooh, we have to start discussing design to study directions.
Oh yeah.
100%.
Oh, so it is 40.
Yep.
Yeah.
How interesting
that. So confusing. Okay, so just so you know, if you want to know what n has to be, it's that first equation you go through. The n times p is greater than or equal to. Okay. Awesome. Yeah, we do have to discuss. Do we want to discuss it tonight or start Thursday?
Well, no. Okay, so open the link below for instructions. Let's just go over the instructions real quick, and then everyone come on Thursday with an idea.
Okay.
Maybe. Okay. Says final project, design the study. Your project must be approved by your teacher before we can collect any data. So list the names of the people in your group. Okay, please write below which group members will be the main writers for each step of the project. The main writer will be the one to collect everyone's ideas and suggestions. They are then responsible to send out the document for feedback and apply the feedback to the document before submitting it. The writer can assign out different parts of the writing as well. For example, if you're in charge of describe the data, you could ask one of your other group members to create and label the charts and send them to be grafted into the main document. I think that means send them to you to be grafted into the main. So we need a main writer for design and study. Everyone writes up and submits their collect the data document. Main writer for describe the data. Main writer for make inference. Main writer for take action. Main writer for the PowerPoint presentation. Everyone fills out a group evaluation and submits it. After you've designated which members of your group will be in charge of each step above, ask your group leader to submit this document with the names filled in above. Design the study. You are to create your own research question based off the interest of the group. Here is a list of few examples of previous studies to give you possible ideas. This list is not an exhaustive list. Be creative in forming your research question. Are there 1,000 chips in every bag of Chips Ahoy? Are brand A paper towels stronger than brand B? Is there a difference in the prices of books at BYU Idaho store compared to online. Are men and women more likely to walk on the grass if they are walking behind someone who walks on the grass? State your research question. Make it in plain English sentence. Something like, we are trying to determine if the average fruit fly prefers a rotting orange over an edible orange. What population are you studying? What is your experimental unit? In other words, what is the smallest entity from which you're collecting a single piece of data to be used for analysis? What is your response variable? Is your response variable quantitative or categorical? Oh my goodness. Which statistical method are you going to use for your study? It should be one of the following 8 methods. Quantitative for one sample, quantitative 1 sample, sigma unknown, sigma unknown, quantitative 2 samples, paired dependent, quantitative 2 samples independent, quantitative 3 or 4 more samples ANOVA, categorical test of 1 proportion, categorical test of 2 proportions, categorical chi-square test, which I don't think we've learned that yet.
No.
What are your null and alternative hypotheses? Please review the format of the hypothesis so that your answer here is in agreement with your answer to step 6. Be sure to state your hypothesis using mathematical symbols if appropriate and define any symbols that aren't obvious. Design the study. It's like 6 pages long.
Yeah.
Which sampling method will your group use? Systematic sample, cluster sample, etc. Refer to lesson 2 for specific methods. Please review the different data collection methods. Please note that true random samples can be difficult and another method may be easier to obtain. If you do choose random sample, please describe in detail how you will ensure the experimental units are selected randomly. Note, haphazard data collection is not the same as random. This requires a lot of thought. Describe in specific detail how your group will collect data using the sampling method stated in the question in step 8. Also, what sample sizes are you planning to obtain per population? This section should have enough detail that a reasonably intelligent person that has never taken the statistics course could replicate your study. Please review the requirements in the text for your chosen method from step 6 and discuss why your study is in alignment with the requirements. Will your project involve human subjects? Will you be conducting a survey? If you answered yes to the questions in either step 11, 12, or 13, go to 13. If you answered no to steps 11, 12, skip 19. Because if we use humans, we have to do a survey approval. I say we don't. Okay, 19, project approval. Your instructor will sign off below if your project is approved. If your project is approved, you'll see a signature below and you follow your steps provided above. If you stray from the steps above, your project will no longer be approved. And then a survey instrument. I say we do not do.
Yeah, that's just if you go through human subjects.
Yeah,
or surveys.
that's it. I say we don't do human subjects unless we use our kids.
That's right. We could. I've got 8. You got 2. How many?
Yeah.
Chris.
Did Chris ever show up?
I don't know.
I say we like all buy a bag of something, and then so like for example, if we do Skittles, if we all buy a bag of Skittles, same size, and we count out all the different colors, that would be our data, right?
Yeah.
Right.
And it would be random because we're all from different areas. We'd be buying them, buy one that single size of Skittles, or something, or M&Ms, and whatever, it doesn't. I'm just trying to think of something that's not too exhausting for us to do.
Right.
No, I think the Skittles one is perfect. It's easy and
I totally will do the put together the presentation if y'all want to do more of the data part, because I think I've proven that it's not really my strong suit.
yeah,
whatever. Yeah, we can break this up.
But I don't want to make final decisions without Chris. But
yeah,
so should we?
I think she's.
Yeah, she's online, but I don't know. I guess.
Can't hear her. Okay. How about? Yeah, I'm on board. How about we think about it, because you could do it in different ways. For example, I guess that complicates it. I was going to say you could buy different sizes of bags and see if proportions are similar, but that kind of changes the game a little bit. No, I think that's fun.
I think we'd all have to buy the same size bag.
Yeah, I think you're right. So,